स्टूडेंट्स, हमारे YouTube चैनल एक्सपीरियंस ट्यूटर में आपका स्वागत है। आज हम लोग डिस्कस करेंगे वेव थ्योरी ऑफ लाइट, जो क्लास 12th IIT, जेई, नीट, एम्स और किसी भी इंजीनियरिंग या मेडिकल कॉलेज के एग्जाम्स दे रहे हो उनके लिए ये चैप्टर काफी इंपॉर्टेंट है। चलिए शुरू करते हैं। सबसे पहले हिस्ट्री देखते हैं। तो व्हाट इज लाइट? सबसे पहले ये समझने की कोशिश करते हैं व्हाट इज लाइट। तो हमें पता है कि लाइट इज अ फॉर्म ऑफ एनर्जी which stimulates our sense of vision। ये नोन फैक्ट था, बहुत पहले से हम ये जानते थे। One of the earliest theory of light about 400 BC was that particles were emitted from the eye when an object was seen, suggested that anything we see, this is only possible when particles are emitted from eye and reflected by that object. It was realized, however, something is entering the eye when a sense of vision is caused. अब ये मानना था हम लोगों का। नेक्स्ट थ्योरी आई 1660 में, जिन्होंने हमारे ग्रेट साइंटिस्ट न्यूटन ने ये थ्योरी दिया और इसे कहा गया न्यूटन्स कॉर्पसस theory of light. According to Newton theory, he proposed that the particles or corpuscles were emitted from any luminous object. Luminous object means any light source. The corpuscular theory of light was adopted by many scientists of the day, and they admitted that this theory given by Newton was correct until 18 until 1680. In 1680, a Dutch scientist called Huygens proved that the light energy traveled from one place to another by means of wave motion. If the wave theory of light was correct, light should corner, bend round a corner, just as sound travels round a corner. The experimental evidence for the wave theory of given by Huygens at that time was proven wrong because he couldn't prove it that light travels in a wave, and therefore his theory was dropped. After about 100 years, that is 1801, Thomas Young got some evidence to prove that yes, light produce wave effect, and he was the first who had come up with the theory and proved experimentally that uh, light could be spread around corners. And again, Huygens' wave theory of light was revived. Newton's corpuscular theory was rejected since it was incompatible with experimental observation, and wave theory of light had played an important role in the development of the subject. In 1905, the great mathematical physicist Einstein suggested that is energy in light could be carried out from place to place by particles whose energy depend on the wavelength of the light. This was a return to corpuscular theory, though it was completely different from that of Newton as with as we can see in the next video. Experiments carried out at his suggestion showed that the theory was true and the particle of energy was known as photon. It was now considered that either the wave theory or the particle theory of light can be used to solve the light problems, depending on the circumstances of the problem. Now study Newton's corpuscular theory of light. Extremely minute, very light and elastic particles are being constantly emitted by all luminous bodies, that means light source, in all directions, which are known as corpuscles. These corpuscles travel with the speed of light. When these corpuscles strike the retina of our eye, the sensation, then they produce the sensation of vision. Different colors of light are due to the different size of these corpuscles. The rest mass of these corpuscles is zero. The velocity of these corpuscles in isotropic medium is same in all directions, but it changes with change in medium. Now study the phenomena explained by Newton's corpuscular theory of light. It was successfully explained the phenomena of reflection and refraction of light by Newton's theory. It was also explained It also explained rectilinear propagation of light. Thirdly, it explained existence of energy and light. These three important things were explained by Newton's corpuscular theory. Now we'll study the phenomena not explained by Newton's corpuscular theory. First is interference, diffraction, polarization, double refraction, and total internal reflection could not be explained by Newton's corpuscular theory. Second is velocity of light being greater in rarer medium than that of denser medium. And third is photoelectric effect cannot be explained by Newton's corpuscular theory. Next is Huygens wave theory of light. So what was Huygens wave theory of light? So Huygens has considered a hypothetical medium known as luminiferous ether. The locus of all ether particles vibrating in the same phase is known as wavefront. Light travels in the medium in the form of wavefront. When light travels in the medium, then the particles of the medium starts vibrating and consequently a disturbance is created in the medium. Every point on the wavefront becomes the source of the secondary wavelets. In the next slide, we'll see the pictures and images to get more idea. So the tangent plane to these secondary wavelets represents the new position of the wavefront. So these are the few important points for Huygens wave theory of light. So can you see this picture? This is a drawing taken from Huygens' book Thesis on Light. You can see light from a point A expands in the wavefront, and B, every wavefront behaves if it is a new source of wave. So this was the original sketch which is taken from Huygens' book Thesis on Light. So in front of you, you have an image or picture where the wavefront, here this wavefront at AB, in the line AB or in the surface AB, is at time is equal to 0. At the initial position, this is this is the wavefront, and after t is equal to c into delta t, means after delta t time, change in time as delta t, the wavefront reaches to this surface DE, CD. This is the new position of the wavefront after time t is equal to delta t. So for this wavefront, the source was the wavefront AB, these points present in AB. So this was only explained by Huygens. In the next picture, you can see what happens for the spherical waves. So you can see two spherical surfaces. One is AA dash and other is BB dash. And this is the source. Red point is the source. So first wavefront is AA dash, and every point on the first wavefront is responsible or is the source for the second wavefront, that is the new wavefront. So every point along the spherical wave front AA dash is the source of new wavelet, that is BB dash. Now one more picture to explain you in more detail about a point source or a source which is very far away. So any source which is very far away, and if we want to consider the wavefronts, then it is like a plane surface. So AA dash is the initial wavefront, then BB dash is the new wavefront, and the source of BB dash is AA dash. Now we'll try to understand the phenomena explained by Huygens wave theory. So reflection, refraction, and interference, diffractions. These are the four important phenomena explained by Huygens principle. Rectilinear propagation of light. This was also explained clearly by Huygens. Velocity of light in rare medium being greater than that in denser medium. This theory was also proven correct by Huygens principle. So these are the three concepts which were clearly explained by Huygens. Now characteristics of a wavefront. So the characteristics of a wavefront, so here you can see three types of wavefronts: spherical, cylindrical and plane. So let us study one by one. Spherical. For a spherical wavefront, the shape of the source is point source, and variation of amplitude with distance, where d is small d is the distance, a is the amplitude, is a is a is inversely proportional to d, or if you take r and then radius r, then it will be a is inversely proportional to r, or a is directly proportional to 1 by d or 1 by r. Variation of intensity with distance. I is directly proportional to 1 by r square. Second type of wavefront, that is cylindrical. The shape of the source is linear source or slit. Here, the variation between the amplitude and distance is A is directly proportional to 1 upon root D, or A is directly proportional to 1 upon root R, or A is inversely proportional to root D or inversely proportional to root R. The variation of intensity I with distance I is inversely proportional to 1 by R. Third is plane. Third type of wavefront is plane. Extended large source. A is proportional to amplitude is proportional to constant in this case, and similarly intensity is also proportional to constant in this case. Now let us study about the characteristics of wavefront. Part 2. The phase difference between the various particles on the wavefront is zero. These wavefront travels with speed of light in all directions in an isotopic medium. A point source of light always gives rise to a spherical wavefront in an isotopic medium. In an isotopic medium, it travels with different velocity in different direction. Normal to the wavefront represents the ray of light. It always travels in the forward direction in the medium. And these are the important concepts for wavefront. And we are ending our today's class here itself. Please let us know how the video was, and we'll soon create the next section of this class, wave theory of light. Please join there in that section. Thank you very much.